All right. Thank you, Isabel, and welcome all back after lunch. Hopefully, this will be a good session for us. As a way of introduction, my name is Rakesh Saha. I'm Director of Product Management at IBM for all advanced networking technologies. We have been on the SDN and OpenFlow for about a couple of years and more. We have some good exposure to this, the early adopters and things like that. So with that in perspective, I will talk about OpenFlow and SDN, and in general, what it means for a large-scale data center deployment. The way this presentation is that I will cover the large scale within the data center. This is if you have really large number of end stations. And Amit here will then cover what it means to have large-scale deployment across data centers from his experience, from his Google background. So that should be also very, very interesting. All right, so welcome again after the lunch session. Hopefully everybody is here and we can get going. So SDN is the new frontier for data center networks. I mean, for folks who have been in the networking for a long time, would realize that SDN as a concept has been floated before in different areas, telecom and wireless recently, and things like that. But from within the perspective of data center, this is something new that is being proposed. As you saw today, it's an early technology in its early stages, but a lot of promise. And a lot of people are looking at it very seriously. These are your enterprise customers and universities and others. And so we are trying to take your data center network to a place that it has not been there before. And we will see what this means. If you look at today's network architecture, even at the element level, they have some inbuilt assumptions about how the network is getting built. And you use your equipments to build that network. But interestingly, this is where the server and storage have been living for some time. And what I mean here is that if you look at the abstraction that is available in the server world, in the storage world, that abstraction is so powerful that it lets you build solutions that are very flexible, that are really limited by your own imagination. But that doesn't happen in the networks today. In the networks, you have to build your network the way it's been prescribed to you, right? So now, let's look at what it means to have a big data center. You can have a rack, a 2-rack, 3 racks. So how many are you looking at? 100, 3,000 if you have a rack of 100 servers with 10 virtual machines as an example. Or is it in millions? I mean, there are customers today who are virtualizing their data centers with so many end stations that they are running into these numbers of millions of end stations that they need to plan for. Some of the really big ones, the service providers, of course, have this today. If you look at Yahoo's numbers, if you have watched Igor talk about his data center, he talks about millions of end stations that he has to deal with. If you look at an estimate of how many end stations, virtual machines, Amazon EC2 has, the estimate is that the Amazon EC2 has about 150,000 physical to-use servers. So if you have 20 VMs per machine, which is not a very high number, you are looking at millions of servers in a given data center. Even for enterprise customers, the numbers may not be as high as millions, but it is fairly large. I mean, there are customers today who have virtualized 70% plus of their enterprise data centers. So what it really means is that, of course, you're really looking at huge number of end stations, and how do you deal with that from configuration perspective, from management perspective, from connectivity perspective. Now, the networks are complex, as we know. If you have built a data center network, you realize that it gets complicated pretty fast. And there are, of course, reasons for that. And it's kind of what has happened over the years, right? And now maybe we are at a tipping point where a new way of networking would be better for current workloads, which are virtualized, which have east to west traffic, which are dynamic, and things like that. So what do you want to do? You want to have business as usual, or you want to change and do something different? That's the choice we have. That's why we are here today. So if you look at data centers, what happens is that each and every element has these 3 fundamental components that we all know very well. One is the data plane, then you have the control plane, and the management plane, right? Now, if you are looking at networks which are at large scale, then trying to configure each and every one of them becomes a big chore. And there are customers who have automated scripts, and they have done a pretty good job of managing the data centers they have, but there also they have to deal with multiple versions, multiple vendors. It gets a little complicated and needs full-time team to just kind of manage that from the configuration perspective. Now, if you look at the complexity in terms of the protocols, of course, each and every element out there runs their own set of distributed protocols. They have their own states. And if you look at any typical data center switch, it's not uncommon to have a data sheet which runs into 3 pages, and most of it is all the protocols that it supports. Whether you use it or not, it will be there. And if you use it, then you need to make sure that it works very well across your entire data center. That gets very complicated. And of course, if you add server virtualization to that, then the scale that you are looking at, it just explodes, as we just now saw. 20 virtual machines today is probably a good average. It will increase, as we all know. And if you're doing virtual desktop infrastructure, then you're really looking at very large numbers of end stations. And each end station, from a network point of view, is something that you need to switch or route. It's just because it's a virtual machine, is a virtual entity in the server, does not change anything for the physical or the virtual network. Your MAC tables, your routing entries, they all have to be populated with those. You have to deal with them as if they all are individual servers. So the other aspect we are seeing is that the networks are getting inefficient from an application perspective. So what do we mean by that, right? So if you look at the networks today, you are trying to manage each one of them the way every element has. So let me just look at this. Right, so every switch in the network has its own view of the network. And the reason for that is, of course, we are building our networks on the distributed protocols. So not a single element in the network has a complete global view of the whole network. What this means is that for certain applications which are getting more and more in number, this is not efficient. They would like to have a complete view of the network so they can actually optimize the network for their workloads. Now, if you look at the network itself, they are closed. What does it mean? It means that if I buy a switch from a vendor, any vendor, I get whatever the vendor provides. Of course, it has full features, it is feature rich, but I cannot influence the way the switching will happen in the switch itself. And if I had a way to do that, maybe I can figure out a better way to do networking for my application. And there are customers who are looking to do that today, but you cannot with the current technology that we have out there, right? This was a survey done recently by ESG Group, and it really talks about the issues that our network admins are facing today in all the areas of trying to manage a network. And if you look at that, it's a long list of issues they are facing, but it is all related to the fact that how to manage, configure, provision, how to do SLA on your networks. And they are looking for ways to simplify this whole thing, and we will see how SDN and OpenFlow can help you do that, actually. So network of the future, what is it that you would like to have, right? So of course, you want CapEx reduction, you want scale to be managed, but what's fundamentally different about SDN and OpenFlow is that it's an open network. It's an open standards-based network elements that you can build based on OpenFlow. And then you can use network as a service or network as an infrastructure. Both use cases are possible, and you can build your network according to your needs. So if you are an enterprise customer, you probably want to build network as an infrastructure, right? If you're a service provider, you want to build network as a service, just like you do that for your servers and for storage today. Now, if you look at maybe I'll skip over this, but this basically talks to the concept of the software-defined networking, and within that, using OpenFlow. So if you look at the bottom, that's what you have, the network element as it exists today on your left-hand side, and then you have the network element as it would be if you were to implement an OpenFlow-based solution. So you take your management plane out, you take your control plane out, you put it in a software outside the network, which is typically a server or an appliance, and your network elements now have this uniform API that they provide to an outside world, which is your controller. right? So once you have that, then you have taken a step in the direction of moving your complexity away from these elements into one place, and that has implications that we need to be aware of. So an analogy is really, I think, describes it well if you look at it. So if you look at the server world today, this is something that we all are used to doing. You can buy the server hardware from anyone. It has a CPU, which is well known, its architecture is known, its instruction set is known. And based on that, if you want it, you can program at assembly level. Of course, nobody does it today. So you have an operating system, and then that exposes an API. And based on that, you get some very well-defined application stacks, your database, your web servers, and stuff like that. But most importantly, you can build your own apps. And I think we all have customers, and customers themselves have this situation where they actually are managing their own applications for business advantages, for agility, and things like that. But there is no such thing in the network world today. You cannot implement a network services of your choice based on equipment that you buy from your vendors. So what will change? You will have the same network element hardware as you have today or in future. On top of that, you can now have an open flow instruction set, which is like an equivalent of your CPU instruction set, if you will. On top of that, you will have a network operating system, which is your controller. And this is the architecture that the SDN community is building to. So if you have time to look at the SDN architecture, this is what you will see. On top of that, you will have these APIs that will be exposed by the controllers, and using which you will, of course, have network services from vendors. And this is where we think the ecosystem will explode, right? Because now anybody who has an idea can build their own network services. But also, most importantly, you can build your own apps now or your own network services. And you would want to do that because you would have applications which can make better use of the networking infrastructure if you had this connection. And today we are talking to customers who are looking at this angle actually very seriously. And it is interesting to see the transformation, because I would say about 6 months back or eight months back, the awareness of SDN and OpenFlow was not that high. So we would go and actually say, hey, have you heard about this new way of doing networking? But now it's the reverse. Now actually we get queries from our customers who are asking us to come and talk about SDN and OpenFlow and show how SDN and OpenFlow can be relevant to them. And what's interesting is that once they understand the concept and the technology, they are able to map this new thing that they can use it for some of their applications that they could not do in the traditional networks. So now, if you look at it at a high scale, what it means at a large scale. So if you have management and control plane touch point, and if this is a very large network, then you are really looking at a complex management and provisioning infrastructure. Now, if you look at the SDN-based architecture, what you have done is you have actually moved your touch points, your configuration management points from each and every element here out to one place in your controller, right? So and this, if you couple this with the fact that now the ONF is standardizing the configuration and management of OpenFlow devices. So now you have a control plane standardization, which is what we all call OpenFlow protocol. And now you also have the config and management standardization that is a work in progress. The first version was released in December of last year, which means that once these things come together, now you can take your control and management plane and put it in one place in your controller, and then have all your management done over here, which means that you are now doing only one touch point versus thousands of touch points, if that's how large your network is, for example. And this should really result in lower downtime. And one of the things that we expect to see in the controller is that you will have rollback facilities, you will have checkpoints, you will have all those things that are enabled by software being the driver behind your controller, so that you can do self-checks, you can do checks on your configuration before you apply. You probably will be able to do your dry runs before you apply your configuration, so that you can be sure that this does not break down your network, as an example. So that should greatly reduce the OpEx cost of the network. That is the hope, right? And then the network management piece, sorry about that. The network management piece should really, have less complexity because of that. Now, the other interesting thing about the open flow and software-defined networking is that once you have an open flow-based network, what this means is that all your elements are now open flow enabled, right? So now that is, and this is your controller. Now, between your controller and the network, you are using the open flow protocol to have your programmable network. What this means is that now you have real-time network statistics from your network going into the controller. Part of it is built into the OpenFlow standards, and that is getting richer and richer with every version of OpenFlow standard. And what it gives you is the real-time view of the network, the link utilization, and statistics of all your flows and things like that. And you can expect that in future you can actually get state of each and every element in real time fed into your controller. So, when that happens, what you're getting is a global live view of the network, and that should let you optimize your network resources in a far more better way than is possible today. Now, if you look at some of the use cases, of course, this is one use case that is, one of the, I would say, the use cases that is in consideration a lot nowadays, which is to virtualize your whole network. And you can do that using software-defined networking and OpenFlow. And if you have a large network, it, I think, helps to have an abstracted view of the network rather than having to deal with each and every physical element itself. And you can do that from an operations perspective. So the controller itself will still deal with the physical network using your OpenFlow protocol, but you as a user won't have to worry about it. What you really want to do is use the network as if it's a service to you or as an infrastructure. So the controller will be able to virtualize the network for you, and you will be able to provide dedicated virtual networks to your departments or your different customers, and all that will be abstracted out for you, right? In the end, when you create your virtual networks, the SDN controller will transform that into actual flows in the OpenFlow network, but that's an abstraction that you won't have to deal with. Same thing for multi-tenancy use case. You can, again, give your customers a choice wherein they can have their own virtual network on top of the physical infrastructure that is in place using OpenFlow and software-defined networking. And when that happens, you can also give an individual controller to each and every user. And this is possible because you have switches, and there are more switches coming which can support multiple instances of OpenFlow, and which means that all of these can talk to a different controller at the same time, which means that you as a infrastructure provider can give your customers a dedicated OpenFlow network, if you will. And that's very useful to do at large scale. And you will see that happening as a use cases. The other use case which really helps to have at a very large scale is utilization of all your common infrastructure, right? So today what happens is that we actually tend to design our networks based on the needs of different individual departments, and this is very much like the days of server infrastructure. Excuse me. So before virtualization came along, every department had dedicated set of servers, right? And whether they used those servers or not, it was for them. They paid for it, even though it was funny money, they paid for it, and they got the servers, right? And it was for them. But when virtualization in the servers came along, the first thing that happened in the IT infrastructure was that they actually put virtual machines from two different departments in the same physical infrastructure. They were able to do so because they could guarantee isolation, separation, all that stuff. Now you can do that for networks too, because now you have a situation where what you can do is build your OpenFlow network, a flat network, right? Because there are really no IP subnets and stuff like that within the network itself. And then you can have your special appliance, a firewall, your load balancers, your deep packet inspectors in a centralized place for a given domain. And then when you create your flows, then the flows which need to go through these services, you can put that rule in the controller so that the flows will go through those services. And then using that, you can then have consolidation of your appliances too. As an example, for The other very interesting thing is this API feedback that you have. I mean, this is something we believe is going to really revolutionize the way we do networking. What it does is that it's giving the SDN controller and you as an application provider or a user a feedback loop, right? So what you can do is you can have the application tell your SDN controller what is the best thing to do for the network. So if you take a load balancer example, typically the load balancers look at, they have 5, 6 servers, they do round robin or some other stuff. They figure out which server could be busiest and they try using based on that. But if you had a way of not only just using, what you can call as a macro indicator of a server's busyness, if you had a business logic which actually tells you how busy an application is, as an example, you can feed that through the API into the controller. And the way controller would take that information, I think you will see it happening 2 ways. There are controllers which will let you add your own module as an add-on, right? Which means that you can preserve your business logic. You don't need to expose any of your secret sauce to anybody, and you integrate with the controller, at runtime, as an example. And the other is that the controller itself has its own API, which gives the state of the network to the application, if application wants to use that. So if you combine that together, so when a new client request comes in, it may so happen that in a traditional load balancer, he may think that this particular server is the best one to use. But now if you think about it, maybe the whole end-to-end path is not the best one for the client, because the network elements may be busy in that path. So now the controller can choose the best network path available based on the network's stats at that point of time. And also it can feed back, take the feedback from the application and choose the right server. So maybe, maybe not the 3rd server is the right one, maybe the 4th server is the right one, if you look at the whole end-to-end view of the network and the application. So these are some of the things that we look at when we look at large-scale networks today: multi-tenancy, self-provisioning, programmable network. And we have talked about these, and you can see that SDN kind of takes you through these use cases and lets you work your network with SDN and OpenFlow to achieve these end goals, right? The API point is very interesting, because if you had a uniform API between various clouds, private, public, and things like that, then you would have an easier transition of your workloads from one place to another. So that's something we expect to happen. Okay, so that was the part of my presentation. I will now hand it over to Amit for the WAN part of the presentation. There you go.